Okay, so here's the second video for moments for FMU6, okay? And this video is going to be very much of a recap of what you did in Maths Unit 4 in Year 12, okay? And it's the fact of equilibrium of body, okay? And then the last video is kind of like putting it all together, okay? So, equilibrium, okay, with a rigid body, okay, it includes two things, okay? It firstly means that your resultant force is zero, so everything going up and down is zero, and everything going left and right is zero. Okay, so there's no resultant force overall. Okay, and the other thing is that your resultant momentum is zero, okay, which means you can go, when you take moments, you go, okay, that means your anti-clockwise equals your clockwise, and so on. Okay, so what's important, okay, is that we're going to think about which way we're going to want to resolve. Okay, so we're going to resolve, if I know my resultant force is zero, then forces up and down should be equal, forces left and right should be equal. Okay, both of those are true. So I can think about either resolving in one direction or resolving in both directions and then take moments about a point. Okay, remember, they all have their benefits. Okay, so the benefits of this top one is that I can ignore distances. Okay, which means basically, remember, when we do moments, we have to do force times distance. Okay, now if I'm missing a distance, okay, or something like that, okay, I can do resultant forces instead because it allows me to ignore those. Okay, whereas moments, okay, I can eliminate a force. Okay, if I take moments about a specific point, okay, I can eliminate one of the forces. Okay, so let's jump into the example by here. Okay, nice and easy one, pretty straightforward from exactly like we would have had in Maths Unit 4. So I've got a uniform rod. So again, remember, uniform means my weight must be in the middle. Okay, AB of weight 200 newtons, so it's already in newtons. Remember, if they give you a mass, you need mg. And length 4 meters, rests on two smooth supports A and B. A load of 150 newtons is attached to 0.8 meters from A. Okay, find the forces exerted on the force. So they kind of give me a rough diagram here. I'm just going to draw one that's slightly bigger, okay, so I can label some more things. Okay, so I've got A's here, I've got B here, okay, and then let's start labeling things. So the first thing I'm going to label is all this forces. Okay, so straight away, it's uniform, so 200 newtons in the middle. Okay, it's also got another weight about over this way, which is going to be 150 newtons. Okay, and then it's going to have two forces. It's going to have a reaction at A, and it's going to have a reaction at B. Remember, these aren't necessarily the same unless it says otherwise. Okay, and then let's start putting some distances on. So first of all, this 200 newtons is in the middle. So I know the distance from there to B must be 2 meters. So total distance is 4. Now I also know that this is 0.8. That's 0.8 from A, which means this little gap here must be 1.2. Okay, now yes, I know my diagram's not necessarily to scale, but we get the idea of what we're looking for. Okay, now from here, I'm going to think about what scenario I want to do. So do I want to resolve in both directions? Do I want to resolve in one direction? Okay, and where do I want to take moments about? Now in this case, everything is only moving up and down. Okay, I haven't got any forces at work left and right, so I'm only going to resolve in one direction. Okay, but first, if I resolve vertically, for example, I'm still going to have two unknowns, which doesn't really help me yet. Okay, so instead, I'm going to start with moments. Okay, now there's two places I'm going to take moments about. I'm either going to take it about A or I'm going to take it about B. Okay, and the reason why I'm saying those two is because let's remember, when I take it about a certain point, it eliminates that force on that point. Now I want to try and get rid of RA or RB. So I'm going to do moments about A simply because it's the one on the left. I've just been working left to right on my diagram. Okay. Now from here, clockwise should equal anti-clockwise. So let's go left to right and work through all the forces. So first of all, RA is going to disappear. The next one's 150. It's going to go clockwise. So it's going to go 150 times this distance of 0.8. Then the 200 newtons is also going to go clockwise. It's put on the left-hand side. And this one is 2 meters away because it's in the middle. Okay, and then I've got the RB is going to go anti-clockwise, and that's going to be 4 meters away from A. Right, from there, I know everything but the RB, so I can just quickly solve it. Okay, it gives me 130. Okay, now I've found one. I've got two kind of things to think about here. Okay, I can either now take moments about B, and that's going to eliminate RB, and then I'm going to have the same kind of thing again, or I can resolve vertically. Okay, now resolving vertically would be easier. Okay, however, let's say you got an answer on this first one and you weren't 100% sure about whether it was correct or not. Okay, you could then think, okay, let's eliminate it so I don't use it again. Because if I resolve vertically, which is what I'm going to do, okay, I use my answer from here. Okay, so if I've made a mistake, I'm going to carry that answer through. Okay, and we're going to potentially lose some marks. Okay, so we're just going to be careful. So I'm going to resolve vertically. So that means everything going up. So RA, in this case, plus RB is going to equal everything going down. So 150 and the 200. And again, I know what RB is, so I can sub it in. And I can work out what RA is. Okay, which gives me 220 newtons. Okay, and there are my two forces. Okay, pretty straightforward, very similar to last year, but now it means that for the last video we're ready to go on a little bit of a harder kind of like understanding of both of these two things that we've looked at. Okay, so keep it. If it's equilibrium, forces are balanced, and your moments are balanced. Okay, so apart from that, I'll see you in the last video.